The universe's second most abundant element is disappearing from our planet, and almost nobody notices. Right now, somewhere in a hospital, a child is having an MRI scan that could save their life. The machine humming around them depends on a gas so light it can float straight off the Earth forever. That gas is helium, and once it drifts into space, it never comes back. We think of helium as the stuff of birthday parties. A few dollars for a balloon, a funny squeaky voice, a quick laugh, and then it's gone. But behind that party trick is one of the strangest economic stories on the planet. A story about a resource that took billions of years to make, that we are burning through in decades, and that most people have never stopped to think about. This is the story of why helium is running out, why almost nobody saw it coming, and why the world is quietly scrambling to secure a gas that most of us associate with cartoon voices and floating balloons. Let's start with something that sounds almost unbelievable. Helium is not made on Earth in any meaningful way today. It is a fossil resource, just like oil and coal, except it isn't made from ancient plants or animals. It is made from the slow, silent decay of radioactive rock deep underground, a process that takes millions upon millions of years. Uranium and thorium, buried far beneath the crust, slowly break apart atom by atom. As they decay, they release tiny alpha particles. Those particles are, in fact, helium nuclei. Over unimaginable stretches of time, this radioactive decay produces helium gas, which then seeps upward through rock until it gets trapped, usually alongside natural gas deposits. That means every balloon you've ever held at a birthday party was once locked inside a rock for millions of years before it ever touched your fingers. It's a strange thought. A gas older than the dinosaurs, sealed away in stone, finally released to make a child laugh for 30 seconds before floating into the ceiling. And here's the twist that makes helium so different from almost anything else we use. Once it escapes into the atmosphere, it is gone. Not gone like plastic in a landfill. Not gone like carbon dioxide that lingers in the air for centuries. Gone as in, it slips past the pull of gravity entirely and drifts out into space. Helium is so light that Earth's gravity simply cannot hold on to it once it's free in the open air. Unlike heavier gases such as oxygen or nitrogen, helium atoms move fast enough to escape our atmosphere permanently. Every balloon that pops, every leak from an industrial tank, releases helium that leaves our planet forever. So we have a resource that takes millions of years to form, and once used, disappears from the Earth completely. No recycling program can bring back helium that has floated into space. That alone should make helium feel far more precious than most people realize. Yet for decades, the world treated helium almost like an unlimited party favor. To understand why, we need to go back to a strange piece of American history that most people have never heard of. In the early 20th century, the United States realized helium had a very different use than parties. It was the gas that kept airships afloat, and airships were, for a brief moment, considered a critical piece of military and civilian technology. Unlike flammable hydrogen, helium doesn't burn, which made it the safer choice for massive floating airships. So, in 1925, the United States government created something remarkable: the Federal Helium Reserve. Buried in underground rock formations near Amarillo, Texas, the government began storing enormous quantities of helium, treating it almost like a strategic resource on par with oil reserves. For decades, this reserve quietly supplied a huge share of the world's helium. It powered the American space program, filled scientific instruments, and eventually became the invisible backbone of hospital MRI machines everywhere. Most people using an MRI machine in the 1980s or 1990s had no idea the helium cooling it might have come from a Texas cave. But reserves, by definition, run down. And starting in the 1990s, the US government began selling off this stockpile, partly to reduce federal debt, at prices that didn't reflect how scarce or valuable helium truly was. For years, helium was sold artificially cheap, which meant the world had little incentive to conserve it or search hard for new sources. This is where the economics get genuinely strange. Helium was priced almost like it was abundant, even though geologically it is one of the rarest usable resources on the planet. It's a bit like selling diamonds at the price of gravel, simply because there happened to be a warehouse full of them. That cheap era is ending. The US government has been winding down its involvement in helium storage and sales, and the artificially low prices that shaped the market for a century are fading with it. Suddenly, the world is waking up to what helium actually costs to find, extract, and purify. So why does any of this matter beyond party balloons? Because helium is quietly one of the most important gases in modern science and medicine, doing jobs that almost nothing else on Earth can do. Think about MRI machines, the ones we mentioned in hospitals. Inside, every MRI scanner sits a powerful superconducting magnet, and superconducting magnets only work at temperatures close to absolute zero. Helium is the only substance that can cool these magnets to the extreme temperatures required, because it stays liquid at temperatures far lower than any other element. Without liquid helium, that MRI machine is just an expensive, useless tube. There is no substitute waiting in the wings. If helium supplies tighten, hospitals face real risks of delayed scans, higher costs, or rationed access to diagnostic imaging. Helium also plays a critical role far beyond hospitals. It's used to cool the massive superconducting magnets inside particle accelerators, including the Large Hadron Collider, where scientists study the fundamental building blocks of the universe. Without helium, some of humanity's biggest scientific breakthroughs simply couldn't happen. Then there's an industry most people never think about: semiconductors. Helium is essential for manufacturing computer chips, the tiny processors inside every phone, laptop, and car on Earth. It's used to cool equipment and create controlled atmospheres during the delicate process of building microchips. That means the same shrinking helium supply connected to party balloons is also connected to your smartphone, your car's computer, and the servers running artificial intelligence around the world. It's a strange, invisible thread linking a child's balloon to the most advanced technology humans have ever built. Helium also cools rocket fuel systems, purges rocket engines before launch, and fills specialized deep-sea diving tanks that let divers descend to extreme depths safely. From outer space to the ocean floor, helium quietly shows up in places we never think to look. So picture the strange irony here. We take one of the rarest, most useful substances in the modern world, essential to medicine, science, technology, and space exploration, and we hand a huge portion of it to children in the form of balloons that pop within hours. It's a bit like using rare-aged whiskey to rinse out a coffee mug. Technically it works, but it feels like a waste once you understand what you're actually pouring down the drain. To be fair, party balloons aren't actually the main driver of helium scarcity, even if they make the best headline. Industrial and scientific use, especially in electronics manufacturing and medical imaging, consumes far more helium than parties ever will. But balloons make an easy, visible symbol of a resource we've taken for granted. Now here's where the global economics get interesting. If the United States isn't the endless helium tap it once was, where does the world's helium actually come from today? For years, Qatar became one of the most important helium producers on Earth, extracting it as a byproduct of its massive natural gas industry. A significant share of global helium at times flowed through Qatari export terminals, making the small Gulf nation an unlikely giant in an invisible market. Then, in 2017, a political crisis hit the region. Qatar found itself blockaded by neighboring countries, and helium shipments were disrupted almost overnight. Hospitals, laboratories, and manufacturers around the world suddenly felt the shockwave of a geopolitical dispute happening thousands of miles away through something as unexpected as a shortage of party balloons and MRI coolant. That moment revealed just how fragile the global helium supply chain really is. A gas essential to modern medicine and technology was being funneled through a tiny handful of countries and facilities, meaning any disruption, political or otherwise, could ripple out into hospitals and factories worldwide. Since then, new players have entered the helium market. Russia has been developing massive helium production facilities in Siberia, aiming to become one of the largest suppliers on Earth. The United States still produces helium from certain natural gas fields, and smaller projects have emerged in places like Tanzania, where scientists discovered surprising helium reserves trapped in volcanic rock formations. But here's the catch that makes this whole situation so precarious. Helium isn't usually mined on its own. It's almost always a byproduct, tagging along with natural gas extraction. That means helium supply is tied to decisions about fossil fuel production, decisions being reshaped by climate policy, shifting energy markets, and the global transition toward renewable energy. As the world slowly moves away from natural gas, the very process that accidentally gives us helium may become less common. It creates a strange paradox. The push toward a cleaner planet could accidentally squeeze the supply of a gas essential to medicine and science. So we're left with a resource that took millions of years to form, that escapes Earth forever once released, that comes almost entirely as an accidental byproduct of an industry the world is trying to move away from, and that has no real substitute for many of its most critical uses. Scientists have looked into recycling helium, especially in hospitals and laboratories, capturing and reusing it instead of venting it into the air. Some advanced MRI machines now use closed-loop systems that dramatically reduce helium loss. It's a promising step, but it doesn't create new helium, it just slows down how quickly we lose what we already have. There's also been talk of extracting helium from the moon, since lunar soil contains helium-3, a rare isotope with potential uses in future fusion energy technology. It sounds like something out of science fiction, and for now, it largely is, since mining the moon remains far beyond what's economically practical today. But it shows just how seriously some scientists and companies are taking the search for helium alternatives. Meanwhile, prices continue to climb. Party balloon shops have faced shortages and price spikes over the past decade, occasionally running out of helium entirely during supply crunches. For consumers, it's a minor inconvenience. For hospitals and chip manufacturers, it's a far more serious problem, one that could quietly raise the cost of healthcare and technology in ways most of us never trace back to their source. Which brings us to a bigger question worth sitting with. How many other resources are we treating as endless simply because we've never bothered to ask where they actually come from? Helium teaches us something surprisingly important about economics in the natural world. Scarcity doesn't always announce itself with dramatic headlines. Sometimes it creeps in quietly, hidden behind cheap prices set decades ago, behind political stockpiles nobody thought to question, behind a gas so light and so ordinary that we let it slip through our fingers, quite literally, into space. The next time you see a helium balloon drifting into the sky at a party, it might be worth pausing for just a moment. That gas took millions of years to form beneath the Earth's surface. It helped power scientific breakthroughs, cooled the machines that diagnosed diseases, and built the chips inside the phone in your pocket. And in a few minutes, it will be gone from this planet forever. Helium isn't running out overnight, and it isn't a crisis that will hit tomorrow. But it is a slow, steady warning about how we value the invisible resources holding up modern life. The economics of weird things often turn out to be the economics of things we never stop to notice, until the day we finally run low. If this kind of story fascinates you, the strange economics hiding behind everyday objects, make sure to subscribe to the economics of weird things. There's a whole world of hidden stories like this one, waiting behind the ordinary things we never think twice about.